Okay, so this is your video for Chapter 9. Chapter 9 is about area, which a lot of stuff about area you already know. Of course, we're going to take it to another level. We're going to put some variables in there. We're also going to do some shapes and some objects that you haven't done area before in middle school. But some of it's still the same. So a parallelogram, the area is base times height. You can remember that because you know the area of a rectangle is base times height. And a parallelogram is just smushed. So it still has the same area, it's just slid over a little bit. So they should have the same formula. What you have to remember is that base and height have to be perpendicular. So this slanted piece is not the height. The height will either be a dashed drawn in line inside the figure, or it could even be a dashed line outside the figure. But what you're looking for is that right angle mark to denote that the base and the height are perpendicular. So make sure you look out for that. Okay, area of a right triangle, same formula as area of any triangle, 1/2 base times height. Again, make sure the base and the height are perpendicular. Area of a trapezoid, 1/2 base 1 plus base 2 times height. It doesn't matter which one's base 1 and which one's base 2, but it does again matter that the height is perpendicular. Okay, all those you know. What might be new is area of a rhombus and a kite. Those actually have the same formula, which is helpful. It's 1/2 times D1 times D2. And D stands for diagonal. So you're going to take the whole diagonal, multiply it by the whole other diagonal, and then cut that in half. Same thing for the rhombus, which mine is not a very good rhombus, so just go with it. Okay, a couple of things to remember. We already discussed that the height and the base always have to be perpendicular, so you're going to be looking for those right angle marks. Remember that the diagonals of a rhombus and a kite are perpendicular, so we're going to be seeing that again with the diagonals. We're also going to be looking at them as triangles too today. And then lastly, remember that the diagonals of a rhombus are congruent. So that can help us. If you only know D1, well, you know D2 as well because they have to be congruent. Okay, let's practice some. Find the area of a parallelogram. Okay, so we want to start by putting our formula. Area equals base times height, and we have to remember that the base and the height are perpendicular. Okay, so I would say that 11 is going to be our base over here, and the height is going to be this guy over here that we don't know. This is going to be our height because it is perpendicular. Now, the 30 has nothing to do with the base of the parallelogram because, look, he's not actually a part of the parallelogram. He's an extension. So that's where people get confused. They want to call the base 30 or even 41, but it's not. That 30 has nothing to do with it. Properties of a parallelogram, if this side is 34, then so is this side. Then I can do Pythagorean theorem with the 34 and the 30 to get my height. So this is 256. Square root of 256 is 16. So the base is 11. The height is 16. So 11 times 16. The area is 176 millimeters squared. Okay, so recap. We got the base. We needed the height to be perpendicular, so we had to do Pythagorean theorem to be able to find the height before we could do base times height. So that's what I mean in Chapter 9, that area is a very familiar concept to you, but maybe we'll add a little bit to it. We have to do Pythagorean theorem before we can do area. Okay? Or like this, where we mix in some variables. So find the height of a rectangle in which the base is 3 and the area is 6x squared plus 24x minus 6 inches. So we know the formula is base times height equals area. So let's plug in what we know. Okay, so we're solving for h. Now notice there's two different variables. Here we have x's and here we have h's. We're solving for h, so we don't even really care about x. There is going to be x's in our answers. All we're trying to do is get rid of the 3, and then we can simplify. 2x squared plus 8x minus 2 inches is the height. Okay, so don't get confused and think you're trying to solve for x or anything like that. No, we're trying to solve for h. So if there's x's in the problem, there's going to be x's in my answer. I'm not solving for h. Okay, let's see. Alright, find the perimeter of a rectangle in which the area is 79.8x squared minus 42. And we can see over here the base is 21. So this is similar to the last problem, only it didn't ask us for the height. Now it's asking us for the perimeter. So we're going to have to find the height, then use that to find the perimeter. So this is just going to be a two-step problem. Still, area equals base times height. So 79.8x squared minus 42 is equal to 21 times h. Divided by 21. H is equal to 3.8x squared minus 2. Okay, so the height is 3.8x squared minus 2. Now our job is to find the perimeter. So perimeter, you know the formula is 2 times length plus width, or base plus height, whichever way you want to think about it. So basically we're going to add these two sides together and then multiply by 2 to get the other two sides in there. So 21 plus 3.8x squared minus 2. So that simplifies to 19. And then we'll distribute that 2. So over here, the perimeter is 38 plus 7.6 x squared centimeters. So not a pretty answer, but the correct one nonetheless. So to start this problem out, we did it just the same as the last one. We set up our formula. We had to divide by the base in order to find out that the height was 3.8x squared minus 2. Then for this problem, we had to keep going because it asked us for perimeter. So we used our formula for perimeter, substituted in our length and our width, or base and height, whatever you want to call it, and simplified as much as we can. Okay, y'all pause here and try 2A about a trapezoid. Okay, find the area of a trapezoid in which B1 is 8, B2 is 5, and the height is 6.2. So this is about as easy as it comes. You take your formula, you plug everything in, and you calculate 40.3. Okay, let's do one with a little bit more work to it. Alright, find the base of a triangle in which the area is 15x squared. So we know the formula for triangle, that's what we always want to start with. And then substitute in what we know. We're looking for the base, but we know the height is 5x. Whoops, I didn't even do that right. We know the area. Okay, so let's solve for B. Now again, remember we're solving for B, so there are going to be x's in our answer, and that is nothing to worry about. So I'm going to divide by 5x first, just because that'll be easier. So 15 divided by x, we still have 1/2 b. 15 divided by 5 is 3. X squared divided by x is x. Then to get off the 1/2, we're going to multiply by 2. So b is equal to 6x centimeters. There we go. So same procedure. Take the formula you know you need, plug in what you know. In this case, I know the area and I know the height, and then just solve backwards. So I divided by 5x and then multiplied by 2. You could do it in either order you wanted to. Okay, y'all pause here and try C, another trapezoid where you actually have to do some solving. Alright, so this one they gave us the area and we had to find a base, which is not that much more difficult. We just have to do some solving. So still we're going to plug in what we know. The area, we know B1 and we know the height. And then we're just going to simply solve backwards. So I got rid of the 11 and the 1/2 by multiplying by the reciprocal, 2 over 11. So 231 times 2 over 11 is 42. And then the 23 was free, so then I could move the 23 out of the way. I would avoid distributing because that's just going to make this problem worse. Get rid of the 11 and the 2 and the 1/2, and then you can move the 23. So your final answer, the other base is 19 millimeters. And you could always go and plug this back in. 1/2 times 23 plus 19 times 11, and you should get 231. So these are always easy to check. Okay. Kite. Find D2 of a kite in which D1 is 14 and the area is 238. So we're always going to start with our formula. 1/2 D1 times D2. Plug in what we know. 238 equals 1/2 14, and we're after D2. And then this is just algebra we can solve. 238, 7 D2, divide by 7. D2 is equal to 34 inches. Okay, y'all pause here and try B. Same kind of thing. Okay, so find the area of this rhombus when we know that D1 is 8x plus 7 and D2 is 14x minus 6. So there are many ways you can go about this. I chose to get rid of the 1/2 first, so you get to pick which one you want it to multiply by. Now here's the most common mistake here is that people want to multiply, they want to distribute the 1/2 here to this parenthesis and to this one, and that's not the way that works. Think about it with regular integers. If I told you to do 5 times 2 times 3, you would most likely do, okay, 5 times 2 is 10, and then times 3 is 30. But if you did the distributing thing, you would say 5 times 2 is 10, and 5 times 3 is 15. 15 times 10 is 150. So, see the difference? You're not distributing it to both parentheses. You pick who do you want to multiply it by, and then you go from there. I can multiply it by whoever I want to. I could just as easily say, okay, 5 times 3 is 15. 15 times 2 is 30. That is okay because I get the same answer. Distributing it to both terms is not okay. So, take your pick. Either do it to the 8x plus 7 or to the 14x minus 6, whichever is better for you, and it should be the one with both even terms. So that's what I did. I left the 8x plus 7 alone, distributed the 1/2, so I got 7x minus 3, and then I could just FOIL. Remember FOIL from Algebra 1. First is 56x squared, outside is negative 24x, inside is 49x, and last is negative 21. Combine your two linear terms and you get 25x, and then that is it. 56x squared plus 25x minus 21 centimeters squared. So, area that you've known about since middle school, a little bit of algebra from last year, and mix it together, and now you've got pre-AP geometry. So, not so bad. Okay, one more of these. Find the area of a kite. Now here we're going to have to use our properties of a kite that we learned in chapter 6 to be able to find all these pieces. Because we know the formula is 1/2 D1 times D2. But we don't have all of D1 or all of D2. But what we do know is the diagonals are perpendicular, so I could do Pythagorean theorem. So I'm going to do it first down here to find y. So 35 squared minus 28 squared. 441. Whoops. So that would be, so that is, square root of 441 is 21. And then remember your properties of a kite, that this one is also going to be 21. Okay, so then we could do Pythagorean theorem again with 29 and 21 to get x. So 29 squared minus 21 squared. That is 400, so that will be 20. Well, let me write that better. That is 400. Okay, so those are our final answers there. All right, now we can use that information. We had to do Pythagorean theorem first before we can now come in and plug in and do area. So let's see. 1/2 D1, 21 plus 21 is 42, times D2. 20 plus 28 is 48. And then, now it should be all downhill. 42 times 48, 1,008 inches squared. So a little bit of work up front. You have to do Pythagorean theorem twice to get your diagonals, but once you have them, then it's just plugging into a formula. All right, last one. The tile design shown is a rectangle base with a base of 4 and a height of 2. Use the grid to find the perimeter and area of the leftmost shaded parallelogram. So we are looking for this guy right here. Okay, so since this is a rectangle and these are divided into 4 equal things, then I can tell that this square by itself is a 1 inch by 1 inch square, and then I have a diagonal cutting through here. Well, what we know about a square, when we cut it in half, now we have a 45, 45, 90 triangle. And we know from our work with that our formula for 45, 45, 90 is x on the square root of 2. So I can tell that not only are the side lengths 1, but now the diagonal is 1 on the square root of 2, or just the square root of 2. So when you go to do this parallelogram, this is still 1 because it's just the height of a square, as is this. And this is the square root of 2 along the diagonal right here. So we're doing perimeter, we're doing area that we're learning in this chapter, but we're using things from chapter 5 to get us there. So find the perimeter and the area. Perimeter would be 2 plus 2 square roots of 2. And area of a parallelogram would be base times height. I'm going to think about this in a different way. You take this parallelogram and you can see that it is divided into 2 triangles, right? Well, wouldn't that be just the same? I'm going to use this picture as an example because I haven't drawn on it. Wouldn't that be the same if I took this and I just flopped it over here and I shaded it in? So instead of a parallelogram with a triangle here and a triangle here, I could do the same picture as a square with a triangle here and a triangle here, and that would cover the same area, right? But it's a lot easier to find the area of a square than it is to find the area of a parallelogram. So I'm going to think about it like this, and then it's super easy. 1 by 1, the area is 1 inch squared. Because otherwise, if you try to think about it as a parallelogram, you're thinking base times height, and you've got all this stuff, and it's just a lot less confusing. You can use the area principle. Just flip this bad boy over. There we go. 1 by 1 is 1. Okay, see you tomorrow.